Hello everyone, and welcome to the Mat 211 review on linear programming. So for this problem, we want to graph the following system to find the corner points. So the first thing we want to do is we want to graph each equation, treating it as an equality rather than an inequality as we have here. So for each of these, and then we're going to figure out which directions we can shade these in. So for our first equation, so let's draw a little graph here. It's going to be sort of straight lines. So for our first equation, we have y minus 2x is greater than or equal to 1. So we're going to start by treating this as if it's an equality, not an inequality. So y minus 2x equals 1. And let's rewrite this so that it's in terms of, it's all in terms of x. So y is by itself. So y is equal to 1 minus 2x. So that's our y-intercept, and that's our slope. So let's say, give ourselves some tick marks here. And in this direction. So we know that for this first equation, our intercept is at 1. And we go down 2. So actually we should get negative here. We go down 2 units in the y direction every time we go 1 positive unit in the x direction. So our next point would be right here. So, whoop. Hang on. So we would have our first line something like this, right? Kind of. So next, let's look at our second equation. Our second equation is y plus x is less than or equal to 5. So if we erase this and make some room again, we're going to again treat it as an equality. So y plus x equals 5. And we'll write this, we'll just subtract the x over, so we have y equals 5 minus x. Or 5 minus 1 times x. You could also write it that way, just so that the slope is explicit. So again, y-intercept at 5. So 1, 2, 3, 4, 5, something like that. Oh, you know what? That is not correct because this slope, so I wrote this originally as y is minus 2x, but it's really y equals 1 plus 2x. So this should be increasing, not decreasing. So we'll say our point should be like here instead. Fixing it as we go. All right, so we're going in this, direction. Something like that. It's about as straight as we're going to get with a tablet. So, and then in this direction, we have again, our intercept is 5, so we're up here. And for every time that we increase x, we're going to decrease y by 1. So we know that our next point is going to be here. If we come up here, our next point would be here-ish. Lines are not, our spacing's not quite right there, but that gives us an idea. So we have something that kind of looks like that. Let's clean up our little guidelines here. So we have our those two equations. And then for x is greater than or equal to 0, well, we could say x equals 0. When x is 0, we know that we're talking about the y axis here, because x is always 0 no matter what y is along the y-axis. So that's our third boundary. So the points where we overlap here, this is kind of convenient. So we're talking about the corner points, right? That's the points that we we have in the center here, we think they're probably going to touch each one of these points, or these intersections between our three lines. But let's just verify to make sure that our sample space is going in the right direction. So we know that for this guy, we have y, if we subtract the 2x over to the other side for the inequality, we have y is greater than or equal to 1 plus 2x. So we know that for this line, we're going to be in this range. And we'll just change our colors a little bit here so that we can kind of look at what we're seeing here. And so we know for this guy, if we subtract our x over, we have y is less than or equal to 5 minus x. So that's this line here. So we're going to be in this space for this one. This is going to get really messy really quickly. That's okay. And then for x is greater than or equal to 0, we'll make this one yellow. Hopefully it'll stand out. We'd be on basically this side of the plane, right? So it looks like our 3 corner points hit all of these. So let's think about where they intersect. So since these two, this one, let me make that a different color. So since this point intersects with the y-axis, we know we can figure that one out right away, right? So we know that our y-intercept here is 5, y equals 5. So this point is going to be 0 because it's the y-axis, 5. So that's 1 point. And then we can do the same thing for this point because it's also intersecting the y-axis. So we know again that our x value is going to be 0. And in this case, our intercept is 1. So we know that this point will be 1. So the last point we want to think about is the point in which these two intersect. So what we would want to do is basically pair these together. And we'll use the lines for this. And so what we're going to do, we know that, actually this one, so we know that we have for our second equation, we have y equals 5 minus x. And we know for our first equation, we have y equals 1 plus 2x, right? So in both cases, y equals the same. So if we take these and we attach these two equations by their y's, we would have 5 minus x equals 1 plus 2x. And so now we can solve for x. So that gives us, if we add an x on this side, let's do that first. That gives us 5 equals 1 plus 3x. Now we can subtract from this our 1 on this side over to this side. And then it gives us 4 equals 3x. And then we just have to divide by 3. So we have 4/3 equals x. So that is our x point where that works. And now we just need to substitute that value into one of these two equations to get our y. So let's use this one. So we'll say y equals 5 minus 4 over 3. So for our x. And we'll just take this guy and we'll give him a denominator of 3 by timesing him by 3 over 3. So 5 times 3 over 3 minus 4/3. That still equals y. So that gives us 15 over 3 minus 4 over 3, which means that our y is equal to 11 over 3 when our x is 4 over 3. So our third point here, of our third corner point, this guy, is going to be 4 over 3, 11 over 3. And those are our 3 corner points. So let me clear that. Before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, please visit the Tutoring Center at tutoring.asu.edu, right here. And then if you go right to this link, it'll take you to the tutor search function. You can also access it from the main website. And the tutor search function allows you to find tutoring services for your specific course. If you have any other questions that tutoring services can answer, such as review services, those can also be found at tutoring.asu.edu. Thank you so much and have a great rest of your day.